guys, this is Professor Janacek, and I want to go over a couple of examples dealing with products of trigonometric functions. This is a type of U substitution. Now these examples are going to specifically have an integrand that has products of tangents and secants. All right, let's take a look at example 3 here. We have the integral of tangent cubed x times secant to the fourth x dx. Now I notice in this case, n is 3, which is odd, and m is 4, which is even. So I really could use either one of those cases. And really, there's no wrong answer. You can pick either one. I'm going to go ahead and use the second version. So I know that my differential is going to need a secant squared. So we're going to start by taking a secant squared and setting it off to the side with the dx. So that gives me tangent cubed x, secant squared x, secant squared x dx. All right, so we've got that secant squared set off for the differential. Now the rest of it is that I'm going to do a u substitution where u is equal to the tangent of x, which means all the rest of this stuff has to just be in terms of tangents, no secants. So that means I need to rewrite that secant squared as a tangent. Well, we'll use the Pythagorean identity for that. Now there are several versions of the Pythagorean identity. I'm going to use the version that says secant squared is tangent squared of x plus 1. Again, make sure you remember, even if you don't have all those versions of the Pythagorean identity memorized, as long as you know how to get it, you're good. Okay, well, we can go ahead and distribute. I'm just going to distribute the tangent cubed. So we have tangent to the fifth of x plus tangent cubed x. And it looks like now we can actually write two different integrals. Going to integrate tangent to the fifth of x times secant squared x dx, plus we're going to integrate tangent cubed x times secant squared x dx. All right, well, what we really have is tangent x to the fifth power in the first integrand and tangent x to the third power in the second integrand. And this allows us to do our u substitution. If we let u equal to the tangent of x, then we know that du is secant squared x dx. And that is exactly what I want. Now, if you'll notice, we have the integral of u to the fifth du, and on the second bit we have the integral of u cubed du. Oh, perfect. Well, the integral of u to the fifth du is u to the sixth over 6, or 1/6 u to the sixth. Of course, there is a constant on this. And on the second one, integrating u cubed du, we get u to the fourth over 4, or 1/4 u to the fourth. Again, there is a constant on this one. Now, these two constants I'm actually not going to write just yet. I'm going to put them all together at the back and give one big arbitrary constant, which we'll call c. All right, so let's go back now, work with x's. Don't really need to change it to u's. So let's see, if we integrate tangent x to the fifth, secant squared x dx, that is 1/6 tangent to the sixth x. Again, I'll put that constant in the back. And then if we're going to integrate tangent of x cubed, secant squared x dx, that gives us 1/4 tangent to the fourth of x. And then all of those constants all collected there in the back. Well, there we go. Not too bad. Let's take a look now at example number 4. We're going to integrate tangent to the fourth of x dx. So in this case, I just have an n value, which is 4. That is not even. All right, so that's not going to work. So and of course I don't have an m value. Even if I considered 0 as the exponent on secant, it's still not. Oh, I guess I could possibly use that. You know what, that's one way of thinking of it. Yeah, we could imagine that this is tangent to the fourth x times secant to the 0 of x dx. And 0 isn't technically even, but it is in the pattern of things like an even, so I could consider this to be that second case. So that means we're going to need, again, a secant squared. Well, I don't have any secants. That's the problem. So let's go ahead and make some. Let's make this tangent squared times tangent squared of x dx. And then we know that, again, using a version of the Pythagorean identity, that tangent squared, and I'll use the second one, I can write as secant squared x minus 1. Again, be careful with that. Make sure you know where that comes from. Don't try to memorize them all. That can be a little challenging. Make sure you know how to get that. All right, let's see. So we can actually go ahead and distribute this. This gives us tangent squared x secant squared x minus tangent squared x. All right, and I think, well, let's go ahead and write this as two integrals. This is the integral of tangent of x squared times secant squared x dx minus the integral of simply tangent squared x dx. Oh, all right, so this one is ready to go. I'm ready to use a u substitution where u is tangent of x and du is secant squared x dx. All right, so that's not so bad. This one, however, I cannot integrate tangent squared. I can integrate a secant squared, but I can't integrate tangent squared. Okay, well, I can integrate secant squared, so let's change that to a secant. So this first one, I'm just going to leave it alone. Minus tangent squared, remember, is secant squared x minus 1. So what we now have are three different integrals. So we have the integral of tangent x squared times secant squared x dx minus the integral of secant squared x dx. Watch this. I'm going to distribute this negative so we end up with plus the integral of just dx. Now again, I'm writing this one in this particular notation for a reason, because I'm going to use a u substitution on that. We'll let u equal to the tangent of x, and then that tells us that du is secant squared of x, which means we're going to integrate u squared du. I don't need to worry about a u substitution on either of the other two integrals. Of course, if we integrate u squared du, that's u cubed over 3, or 1/3 u cubed. Of course, there is a constant that I'm going to add, but I won't add it until the very end with the other two integrals. So here we go. Back to x's. I'm going to integrate tangent of x, parentheses squared, times secant squared x dx. That's going to be u 1/3 u cubed, but u again is tangent, so that's tangent cubed x, minus, now this piece here, the integral of secant squared x dx, that's just tangent of x. And then finally, integral of dx, that's just an x. And then we have all of the constants from each of those integrals there at the back, plus c. And there we go. Enjoy!